Thanks. Oh, it's quite loud, actually. Um, my name is Alex. As you've seen, Bigstep is a company specialized in big data, and we're a cloud for doing big data. We're a bare metal cloud, and there's a lot of very, very interesting things that I can tell you about it, but I'm not going to tell you about it right now. The talk is about something that we see with our clients a lot, and is going to be about experimentation in general in companies and how you can do that. And more specifically about data lakes, data laboratories, and some of the tools that we use to be able to do that in various companies. So before I get started, I want to kind of ask you, who's a developer? Raise your hands. Or like the vast majority. Who's a sysadmin or DevOps or that kind of stuff? All right. Oh, little majority. Who's business or CTO level or something like that? Great. So I typically do technical talks. So this is going to be a bit less technical than I'm used to. It's more, if you like, strategic. So anyway, without further ado, my point of the entire talk is that innovation is always a consequence of research. And we don't see enough research in companies, actually, to justify certain decisions that are taken. Many decisions are still gut decisions on the business side. People just kind of think they know what they want to do, and they just start doing it and invest millions of dollars without prior research in various fields. And what we're trying to do is we're trying to kind of democratize what's called data science. You know what data science is, I suppose. You've seen a lot of big data related talks recently, and big data is not a new thing. Data science certainly is not a new thing. But what we see more often is that it's no longer something that happens only in, let's say, higher stratosphere level of very, very technical people and very skilled AI or, I don't know, academician, people from academia, but also something that can be done by regular people in regular companies. And there are tools out there, which I'm going to talk about, which allow you to do a lot of these very fancy things, including machine learning, without necessarily having to write code. I know you're developers, but there's a role for you there as well, and you will see what that is in this new ecosystem. And again, it's not such a big deal, right? And the center of this, let's say, revolution that started to happen in the last, let's say, couple of years in this field is due to this concept of a data lake. Who has heard about a data lake before this? Okay. So a data lake, for those of you who don't know, is basically a data laboratory. It's a place where you concentrate data from multiple different sources and that you use to explore the data that's in there and to do, let's say, analytics, to do predictive analytics, to do a little bit of machine learning, try to understand your customers, try to understand the data that you have, do specifically correlations between the data. All right. And data lakes, as opposed to all the other, let's say, prior attempts of doing that, stand out because of two reasons. But first of all, you can aggregate data which is unstructured along with structured data, and I'm going to give you some examples. Things like JSON documents, stuff that comes out of REST calls, along with structured data. And it's cheap. That would be like the second option. And so again, people have been building these kind of infrastructures for a while now, but they were used to be done using code, right? So you write some Python code, you get data from one source, import it in the other source, you do a lot of these things programmatically, which is fine, it's good, but the people that have the skills to do this are actually in very, very high demand and in short supply across the world. And if you're a company like TfL, for instance, that's one of our clients, that has to aggregate data from Metropolitan Police, Transport Police, magnetometers. They have every couple of meters all across London. There are some sensors embedded in the ground that monitor the traffic that goes on top of them. And so they have loads of data, right? And it's not correlated in any way. The way they're currently doing these, let's say, data science efforts to answer the Mayor of London's questions about the state of the traffic is that they use R, as R programming language, and R-related tools, and everything that they do on their laptops, right? So they cannot currently correlate and aggregate data from all these sources and run the same type of, let's say, analysis, statistical analysis and predictions on that data unless they have some place to put them. And this is this data lab thing that I've been telling you about. All right, another customer, which was actually, this was set up yesterday. So what they have, I don't know if you heard about them. This is the biggest golf book. It's kind of a booking.com for golf. So whenever you have to go out and play golf somewhere in Mauritius or some other exotic country, you call these guys and they set you up. And so what they have data from, SQL data from a data warehouse. They have a kind of a call log service from a company called Infinite Cloud, which, because they're a phone-based company, they have about 200 people answering calls, and each customer receives a different phone number on the website so that they can track who has gone through which steps across the website and ended up calling, and what that generated in terms of actual revenue, because there's disconnect between the web and the actual purchase process through the phone. Anyway, so the data is aggregated in Infinity Cloud, which is on top of IVR. Then there's, of course, Salesforce data and Google Analytics data for the actual website. And they have all these tools. There are cloud-based tools, right? Infinity Cloud is a cloud, Salesforce is a cloud, Google Analytics is another cloud, and they have internal data, right? But it's not aggregated. They cannot cross-match, cross-correlate, create graphs that kind of match all of these. So you need a place to put them. You need to be able to extract the data from all those various sources, right? Do a lot of, let's say, REST calls to gather their data, and it depends on the service, what type of data it is, right? So this is how a data lake looks like, technically. Right, so the components, the basic components are, coming from let's say, from bottom to top, right? It's HDFS and Cassandra. You know about them. You've been using them probably. We typically use Parquet and Avro, which are file formats. For those of you who don't know, they are within this HDFS, which is a distributed file system. You can store data in various formats, and you can query it directly. You don't have to have necessarily a service like you have with MySQL to go through and access MySQL's data. This Avro thing is more democratized, and you can access it from multiple tools like your little own Python script or Scala script, but also Spark, Hive, Impala, and all the other tools. Anyway, so that's the file format that we typically use. Parquet is a little bit faster than Avro. Avro is like a JSON but binary. Then we typically get the data warehouse data, that's SQL, into this thing offline using something like Scoop or Spark, Spark directly. There's a Yarn cluster. Again, actually I should have asked this before. Who has installed Hadoop on its own? All right, so Hadoop has two main components. The bottom line, which is a distributed storage thing, right, which is a service that resides on every server in the cluster. And there's a distributed computing scheduler that runs on top of it, and that distributes workloads on all the machines, right? And part of this workload is Spark. Spark is an evolution of the standard MapReduce framework from the typical Hadoop distributions that you might have used or not, in the sense that it is in memory. It stores everything in memory. It caches things in memory. So because memory is so much cheaper now than it used to be, this is an order of magnitude faster than what you already had. And so it kind of, to some degree, can get to the level of performance that you get from a traditional database, but of course, much bigger scale. right? So I highly encourage you to look at it. Typically, what we see recently is if you have a problem, there's only one solution, that's Spark. I mean, regardless of the problem, we kind of see that happening over and over again. And on top of Spark, and by the way, Spark is a framework, right? It distributes workloads. But the actual code that you write in Spark can be written in multiple languages, Scala being one of it. It's a functional language. Have you ever written anything in Scala? Java? Yeah? Okay, good. So Scala is a JVM-based language. It's a functional language, but it's JVM-based, so it runs in JVM. Can use all the stuff, all the jars that are available into Java applications, but you write code in a much simpler and leaner way, so that's automatically parallelizable, if you like. Anyway, so I can talk to you about that later on, so I highly encourage you to take a look at that. Right, on top of Spark, there's something called Spark SQL, which is an entry point to the Spark cluster that translates SQL statements into, let's say, MapReduce code, although Spark has a much more complicated translation mechanism that actually generates code, bytecode, Java bytecode that gets submitted to the actual executors. So it's pretty fast. If Spark SQL is not fast enough, though, although it's the most versatile one, there are alternative solutions, including Cloudera's Impala, which you might have heard is a SQL on Hadoop solution to kind of do this translation, and XSO, which is a German company. They do a very, very fast SQL database, another NoSQL database, but one that doesn't have a master. So you can scale it very, very well. And it's in memory. It's an MPP database. It's very, very fast. All right. Next. On top of that, what we typically do is we add a visualization tool. And I'm going to show you screenshots of all of this so you kind of know what I'm talking about. Zoom data is very cool. It's server-side. There's Click as well. These things are used for a non-technical person to see the results of your work, right? And I'm going to give you more details about it later on. Then we have Zeppelin and Jupyter, which are notebooks or notebook tools. I'm going to tell you more about it later on. And then you have to, of course, in certain scenarios, ingest real-time data. The guys from Bolt.com, they had to ingest clickstream data, right, as things happen on the website. Right? And the way to do that is not through SQL, because that's really slow and it's a single endpoint. The way to do that is typically through a distributed queuing system. What's typically used is Kafka. Recently, and the reason for that is because Kafka is distributed. So it has multiple workers and partitions. So it's like a little own, let's say, NoSQL database that helps you store the data while it's in transit. It helps you keep track of where you left off and consume the data properly without losing anything. And you can have multiple producers, multiple consumers, so you can scale. So you add the data, let's say underneath, right, the database directly into the file system. All right, I know this is a bit abrupt, but it will make more sense. Now, I think that was like the most technical part. In this data lab concept, right, that we are trying to promote, not necessarily, the industry in general is building up, there are multiple roles, right? And within companies, the problem has always been that a few had the power, and everybody else could not, as I said, could not justify their decisions properly. So what it is now happening is that this everybody else guy here has access to this data lake, to his very own data laboratory, to tools that are not necessarily programmed, that have to be written, to do experiments and to execute, joins and to generate graphs. If you like, it's let's say a generalization of Excel to to do big data with it. And I'm going to show you some screenshots and tell you what that means. But this guy has to have help in order to understand what happens there. And I think this is the point that I want to make for you guys, because you are developers. There are other development practices, not necessarily, let's say, mainstream development or production development. Being a data scientist and developing code for specifically this so specifically this domain is something which is really, really interesting, but your role is also very political because you have to be able to understand what the business is doing, to have to be a domain expert or at least be able to talk with domain experts in every, in the field of your company and help everybody else run things on their own. And of course, you have to have the domain experts and the people from IT to actually create this infrastructure that I'm talking about, which is pretty complicated. But they do that once, typically, and they just help run it. But then you need a data scientist, which, again, is a developer and a little bit of mathematician combined. But I would say that the maths part is not that critical at this point. All right, so there are low-level tools. You use them like this, right? HDFS, DFS, something, something. Looks like this. You have to be able to use bash and shell scripts and stuff, right? And then there's the notebook. The notebook is the equivalent of bash, but for data science, right? And there are two of them, actually more of them, but those are the most used. They look like this. This is a pretty novel concept. I'm pretty sure you haven't actually seen it. It is about embedding code, text, graphs within the same thing that can be executed, right, and shared with others. This is really powerful because you don't write code, in isolation somewhere in console, nobody sees it, and then you have to write a report out of it. You combine everything into a simple thing, right? And then there's such a thing like you can do machine learning without writing code, and the tools to do that are H2O and potentially Seahorse. This is how H2O looks like, right? You have some input fields. It works with HDFS underneath, right? So you have to have the data there. But if you have it, then you can just select a few things and run a k-means analysis on it or some deep learning algorithms. You don't have to be able to write them. You just have to know what they do and understand them a little bit. So this is where I think the role of a data scientist should be from now on, is to educate people from the companies to be able to do that, right, on their own. Right, and then there's the highly visual thing, visual analytics, and this is a screenshot from Zoom data from a customer that we have actually quite recent, and it looks like this. And you set it up, you can aggregate things and create your own dashboards. So I don't really have a lot of time left. Actually, I think like a couple of minutes. So I'm going to skip the data science workflow part, the scientific method part, and tell you how what another customer of ours has done, called CitySprint. Basically, they track. They're kind of a same-day delivery company. They move parcels from one place to another within London or within the UK. And this is the driver's journey. Right? They have information from their mobile devices to GPS information, right? And what they do is they've created this heat map of places where parcels are generated. Right? They've compared it with what they currently have in terms of aggregations locations. And then they run some k-means to seeing where would other concentrations of parcels which are generated occur. They map that to traffic across the UK. And now what they can do is they can, clicking on any of those centers which were automatically detected by using k-means, they have this little graph that tells them the demand, predicted demand per hour and per day of week, right? So they can tell a driver, if you're in this position, just stay there, but live at about, I don't know what's written there, 1,700 hours, because chances are you're not going to have another parcel. And that depends a lot on the use case, but this is the outcome of typical data lake, the outcome of typical data scientists working properly with their counterparts within specific companies. It's really interesting because it evolves and you use very interesting tools. So I highly encourage you guys to look into understanding Scala, look into data lakes in general, try to convince your partners, co-workers to build one. and do cool things like this, and automate your business, and Uberize your business, and help transform the world in which you live. That's it.